All right, we're gonna go ahead and get started. So thanks for coming. This is a Ask Us Anything panel on service mesh and microservices. This will only be interesting if you guys have questions and things you want to talk about. It's not a presentation. Maybe we'll start with introductions. I'm Jason McGee. I'm from IBM. I run our container and Kubernetes services at IBM. Matt, you want to? He has a mic.
Hi, I apologize. I'm doing my normal conference, almost losing my voice yet again. I'm Matt Klein. I work at Lyft. I lead our network team at Lyft, mostly known these days for working on the Envoy proxy.
I'm Dan Berg. I'm with IBM. I'm the lead architect on our IBM Cloud Container Service. Also involved in the Istio project, involved in the steering and technical committee.
Hi, I'm Sven and I work at Google. I'm the lead of the Istio project at Google and one of the Istio founders.
My name is Joy. I'm working for Google too, and I'm working on the Istio, in particular config working group.
Great. Maybe I'll kick it off with a question to you guys, because we've been talking about service mesh a lot. So how many people in the room think they understand what service mesh is about? Let's start with some basics. All right, good, because you wouldn't have come to this panel if you didn't. So maybe we can start with a little bit of perspective from you guys on kind of where we are with service meshes. What are some of the common problems that we see customers starting to try to solve with service meshes? Just a little context on kind of what are the adoption patterns that we're seeing. Anyone want to start?
Okay, so I'll jump in on that one, at least initially. So definitely working with a number of customers, moving to microservices. So as you're moving to microservices, adopting Kubernetes, hopefully, usually, they're dealing with problems that they have to solve, right? They're looking for ways of being able to manage all of those, the complexity of all those microservices. And what I'm seeing is some interest in adopting a service mesh, and when they're talking with us, oftentimes it's Istio that comes up. They're looking at ways of different patterns of adopting Istio and how do they go about adopting it. And I've seen several different patterns. One of the patterns is just getting a better understanding of what's running in my environment. So installing Istio, enabling the sidecar proxy with Envoy gives them immediately a set of metrics and telemetry that from day one, just by turning it on, they start to be able to see, oh, these are the interested services that are participating in my mesh, and here's the traffic going between them. Here's the metrics of all that information between the traffic between all of their microservices. And that alone has added a huge amount of value. And there's many other patterns if anyone wants to join in and describe some of those.
Sure, yeah, I think we've seen something very similar with the people we've been talking to. Although we have different sets of people that are interested in different things, which is kind of fun. So there are people that just are like, hey, I want to know what the heck's going on. There are other people that are really, really interested in the security aspects. Yes. They tend to be banks and financial institutions, things that need to protect their data really, really carefully. So they're very interested in that. And then we also get people that just want the traffic management parts. So they want to do canary rollouts. I saw the thing on GitOps earlier, right? People really like that kind of just roll things out slowly and try out the different features and get the retries and all that kind of good stuff.
Great. So let's turn to you. Anyone have a question they want to start with? And I can walk around with the mic. Yep. I'll just pass the mic around. That way it'll be easier.
So I have followed a lot of presentation on this track service mesh. And then just before this one, I went to Nat's presentation that I would qualify as a traditional message-oriented middleware. And within our company, we are thinking about moving from a message-oriented middleware towards a service mesh. What would be for you the main difference and the main reason to move from a message-oriented middleware to a service mesh architecture?
I guess I would start by saying I don't think it's an either or. I think there's I think we're seeing a big movement towards people building dual architectures, that are both message-based as well as pub/sub. And I think my recommendation would be to look at the problems, that you're trying to solve from a business perspective. And I think you'll pretty naturally see that some of them are pub/sub problems and some of them are, messaging problems or just basic RPC problems. I think the larger question is, can service mesh help you with pub/sub? And so far, I think that's not the case. I think most of the service mesh deployments have been, very RPC focused. I think it's going to change. I'm expecting there to be Kafka support in Envoy probably by the end of the year, and a company already did NAT support in Envoy. So I think you're going to start seeing actually even there being like a dual deployment where you may do pub/sub to RPC or RPC to pub/sub. So I think it's an either or.
Yeah, I definitely agree with that. We actually had a meeting. I don't know how long ago this was, a year ago or something. We met at the IBM offices and we discussed sort of the future of Istio, and
that one came up.
That one came up very, very strongly on there. It was like, we need to solve messaging. It's just we can't do everything at once, right? So we're starting with RPCs, but it's definitely in the pipe. Yeah.
Hi, what you'd say are the most prominent advantages of mesh architecture over the more traditional reverse proxy setup?
So versus, I didn't hear the second half
Traditional
of
reverse proxy kind of setup.
Well, definitely in the modern service meshes, one of the biggest value propositions is that you get the benefit of taking a lot of the specific complexity that you have to add to your application. That gets removed from your application and is pushed into the mesh itself, into the network, to handle a lot of that complexity, the routing decisions, the metering, the telemetry, the policy enforcement, the security aspects, mutual TLS communication between the services. You don't build that into your application. That's extracted out into the mesh itself. So that's a huge advantage over a traditional solution.
I guess the one other thing I would add is I think the kind of traditional reverse proxy or edge architectures where you have something sitting in the edge were designed around a kind of more classical one-directional tier flow. You're coming in from the outside, you're going into a web tier and back. And I think with the adoption of microservices, you have a much more complex flow of messages between services. Some things are on the edge, some things are dual purpose. They're kind of edge facing and internally facing. And so distributing that function throughout the services is a more efficient way to manage it than to have this kind of edge that you're coming through at all times.
Yeah, as an anecdote, at Google we used to run a giant edge reverse proxy written in Java, and it got, I don't know, we were running in, not quite double-digit millions of QPS, but close to that. And we just started to fall apart scaling-wise. It just couldn't handle it. And so we rewrote everything from scratch as a distributed proxy, and now it's 10x that and no problem. So there's definitely scaling limits to the edge proxy model as well.
Question?
Hello? So starting from how many microservices we should consider a service mesh. For example, if we have a solution with only 3 microservices or 4 microservices, should we consider a service mesh or not?
So I would say absolutely. It depends on what you're getting out of it, but if you want to do canary rollouts of any of those services, so if you just have one service and you want to do canary rollouts, it can help you. If you have 2 services and they're talking to each other and you want that secured, it can help you. So yeah, I think unless you don't run anything, then you should probably use the service mesh.
If the number's 0.
Yeah, I would also add to that. I mean, day 1, no, you don't need it. Day 2, if you plan on operating it, yeah, you probably want it.
Yeah, I agree with that because how we evolving to have service mesh is we looking at those common features between services. So we kind of giving a abstraction of those common features and provide it into service mesh, and you can do it through configurations. And so when you're looking at each services, then developer can focus on their business, and they don't need to worry about developing all those networking code or how to worry about how I can kind of putting explaining to my code how to get connected and putting security authorizations, you don't need to worry about all this. And we were putting like features like transcodings, and you can pretty much write your service in gRPC, for example, and we can having a API service for you to expose as HTTP REST APIs or things like that. So there's a lot of advantages, and I don't think really you need to think about if we have to do service mesh at the scale, and it's pretty recommended starting day one.
I will give you probably a slightly less bullish answer. I think I agree with everything that was said in terms of the benefits are large, but I would say that we're in pretty early days of kind of some of the tooling around these products. And it's not free to roll this out. So it's like, at Lyft now, we have hundreds of services, but we have, my team owns a bunch of things that's not just Envoy, but we have like 4 or 5 people that work full time to operate and run Envoy at Lyft. And that's not scalable for a small company. Like, I don't think you're going to get the ROI of like rolling out a custom Envoy or Linkerd or whatever thing, like, but by yourself. I mean, it's just not going to be there with like, potentially a 4-person startup. As the tooling gets better in the sense that you can do like a hosted Istio or some other hosted product, I think it becomes a lot more compelling. But I would just say that, you have to look at what the cost is right now. And it's like, if you're trying to go to market and you just want some services that are running, I would actually say, you might not want to do it right now, because I think you're going to spend a bunch of time like learning how to operate it. If you have 4 services and they're really important and you're going to lose a lot of business if you don't understand what they're doing, then I would do it. But it's like, it's not a slam dunk. It just depends on what your business situation is.
It's probably also worth noting that if you introduce, the mesh isn't free, as Matt was saying. You have to understand from a scale point of view, there is a cost to running a mesh, right? There's a cost to the data plane, but there's also a capacity cost, right? It's small, but depending on the number that you run, if you're running 3 or 4, you're not going to notice that cost. But you got to be aware that as you grow, you do have to manage the control plane if you're installing it yourself. You do have to manage the service mesh helps with complexity, but in and of itself introduces its own set of complexity, because there's a lot of policies potentially over time that you now have to understand and manage those. So having a good CI/CD process around those things is still critically important in order to support those. And you're also dealing with Kubernetes and Kubernetes scale numbers, right? There's like physical numbers, like the number of containers you can run on a node. And that's going to have some bearing as you scale up. Okay, you're adding a sidecar to every pod. Well, that's a container. If you're running 3 or 4, not a big deal. If you're running 10,000, that's a big deal. And they start to add up. So you got to be aware of that and what the impact is to your system. So nothing's for free.
Okay, just ideological question, just to hear your thoughts about this. With the advent of distributed tracing and annotated distributed tracing, are access logs are still relevant, or we can just replace them and stop writing them? I just use tracing.
I didn't quite catch that.
The question was, given that you have distributed tracing, are access logs still useful? I would say yes. I think I like the way that I talk about it is observability in modern systems really has 3 components. It has metrics, tracing, and logs, and I think you need all 3. And I actually think they're typically used for different things. Like, I think metrics you're going to use typically for firefighting, maybe some logs. Tracing still today, no matter what the tracing vendors will tell you, I don't think it's super useful for like a firefighting perspective. I think it's really useful from a performance perspective, like to know what's going on, kind of analysis. But honestly, nothing beats access logs for certain types of problems. And that's actually why in Envoy recently we built like a gRPC access log streaming system. And now at Lyft we have a huge amount of effort going into taking those protos and putting them into like a Hadoop style MapReduce system so that we can do long running queries. It's like there are just questions that you cannot answer any other way other than doing potentially long running queries over access log data.
Very good.
Yeah, no.
I love when we only get one answer. It's awesome.
Hello. I have a question regarding, we are creating a product that is installed in someone else's cluster on premises. And during development, we'd like to strip out all that circuit breaking stuff and put it to a service mesh. But the service meshes are quite cluster infective. So if you want to use it, you use it for like all your services, basically. At least that's what I understood so far. Are there any possibilities how I could make use of it in a limited set of use cases?
Yeah, that's a great question, actually. So today, not really, at least not with Istio. So, right, because you have to kind of install the whole control plane and stuff. With just Envoy, absolutely, you can do that. You can just run Envoy on your parts, and you'll get it for your connections. That is something that the Istio project has looked at as a potential area to try to fix more. And I think sort of to what Matt was saying, as companies start offering managed versions of this stuff where you don't have to run the control plane yourself, then actually you can get all those benefits just in a couple pieces. So I think it'll come. It's just not there yet.
Yeah, there's one thing that I would add to that is that I think the way that people deploy service meshes currently, there's kind of two ways of doing it. The first way is what I would call the fully transparent service mesh, and that's typically where you'll run the sidecar, you're going to use a bunch of IP tables, magic, to kind of redirect a bunch of ports and things to your sidecar, and it's all magical. We actually don't do that at Lyft. We don't use IP tables at Lyft. So the way that we deploy at Lyft is applications are aware of the mesh. Like we have thin libraries that do various things and they know to connect to Envoy on a particular port. With either of those methods, with either IP tables or prior knowledge, like with just Envoy or or other proxy, like you can definitely do partial rollout because you can say that only this service or this port goes to the mesh, everything else goes direct. So I think that the flip side of that is that just Envoy, there's a lot of configuration and a lot of complexity, and it's not to be taken lightly. So the benefit of the control planes, like Istio and a bunch of the other products that are now coming out around Envoy, is that they make some of these common case configurations easier, but they don't always support some of these split use cases. So you might need to go down to the raw thing depending on what you want to do.
Yeah, and definitely Istio has a certain way, as Matt was pointing out, how it programs the sidecars, and a lot of that is to keep things simple, right? You do have the ability, though, if you want to roll out services in your cluster, you can enable sidecar injection for only a subset of the namespaces, and using it is a fairly granular. Well, it's not individual services at this point, but at least at the namespace. So it's at a larger, more natural division in Kubernetes, but you can isolate and set up that some namespaces are in the mesh, others are not. So if you want to roll it out incrementally that way, you can separate out your services in the mesh that participate or do not participate.
I just want to add one thing, which is because this question is really interesting. I think we haven't really spent time thinking about, okay, if someone has a Kubernetes cluster, is there a way to create a Helm chart that's sort of service meshified and install it in the cluster without first getting the cluster as part of a service mesh? And and that's kind of what you're asking, I think. And we haven't spent time figuring out if that's possible or how to do it, but it is really interesting. Yeah.
Great, thanks.
I think if everyone just runs the service mesh, then the problem goes away.
It all goes away.
Okay, other questions? Oh, here in the back.
Thanks. So we're using Istio for service routing within a cluster, and we're currently getting at a state that we're not only getting lambdas executed in our kubeless runtime that we're running there, but we get more and more the demand for like full containers to be executed. And since we treat them as untrusted code, we need to find a way to sandbox them. So one idea that came last week after the virtual Cubelet announcement was to actually use virtual Cubelet for that and basically push the old untrusted code into Azure Container Instance or alternatives to that. But we're not really sure yet how that's going to fly with Istio and how would Envoy work with it.
Yeah, so I don't.
We
can barely hear you
yeah,
up here,
it's hard to hear up here, sorry.
Oh, it's hard to hear up there.
Yeah.
All right. I'll try to summarize. Tell me if I get it wrong. So the question was, in his scenario, they have cases where they need to be able to run untrusted containers. They're using Istio or using Istio or using Istio. And so one of the ideas they had was to use virtual kubelet to redirect the untrusted containers into something like Azure Container Service or something like that. And his question is, if you did something like that, how would Istio play with that? Would that be a problem or not be a problem if you did that? Is that right? There you go.
So you got to get the. I was just thinking, you got to get the sidecar in there.
Yeah, so if
It's got to participate in the mesh.
so you have a cluster, you have your local cluster, and then you have a different cluster or whatever on a provider running. Okay, so. Well, I don't know if it helps or not, but one of the things coming out actually in the next release of Istio is the multi-cluster support. So being able to connect multiple clusters into a single mesh. You do have to the earlier point, be able to install Istio in each of the places. But then once you do that, absolutely, actually, Istio gives you a lot of benefits in that model. I think your particular case would be something we'd have to maybe talk more about and figure out how to do that.
I'm not sure it's too relevant. If I understand your question correctly, you still have a ingress. It has basically has a gateway and accepting traffics from outside of the mesh, and also allows to have an egress and directing traffic from inside the mesh to outside of the mesh. So if you think it's worthwhile to go through those traffics through gateways, and we have a rich settings and you can do like security terminations and all these features, maybe that could be useful. If some of the piece of your service running outside of the mesh, and we can see it as a external extra mesh traffic, and to some of, you can put in most of the services inside of your mesh if you want to manage them uniformly.
Yeah, that's a good model. All right.
Is there any support to route traffic to a like partition service, or is there any plan to support that kind of use case?
Can you hear that? A partition? What do you mean by a partition?
Let's say I have a backend service that's like a stateful service and it's partitioned. Yeah.
Like stateful routing.
Yeah, so I can't speak for Istio. I don't know what Istio exposes currently. But in Envoy, we have two types of consistent load balancers implemented. We have a Katama ring hash load balancer, and then we have a maglev load balancer. It's also a consistent hashing algorithm. And then we have a way of hashing based on cookies or like IP addresses and stuff like that, and it's pretty extensible. So we can add other things. I think Microsoft is actually doing some work around like there's a bunch of stateful stuff that they do. So they added like range routing from headers. So I mean the answer is yes. In fact, like we're using Envoy at very high scale to do Redis at Lyft. I think I need to know a little more about your specific use case to answer yes or no, so happy to talk after. But I don't know if someone wants to cover the Istio case.
Yeah, I mean, from the Istio case, that can be exposed. I mean, if it's supported from Envoy, that can be exposed through the routing rules to make available as part of the decision when you set up your routing policies and the routing rules. It ultimately comes down to, if it is supported, then it's something we can expose through.
Great. Who else?
There's someone over here.
Is there a point at which service mesh gets too complicated to manage? Istio already is quite complicated, but in all the stuff that people are throwing into it, like, is there a point, can we make it simpler at some point, or is it just going to be large?
This is my personal opinion. I think that the way that the industry is going is that like we're in this middle ground right now where we were going from bare metal VMs, now we're doing containers, but containers is not the end state. Like the end state is probably serverless, which is really in its infancy right now. The reason that I bring that up is that in the long run, I don't think you configure anything. I mean, like I think it just basically works. We're probably 10 years away from that, but we're kind of we're just in this middle ground where people are building these kind of microservices, distributed architectures, and it is really complicated, and I think that there's going to be a set of vendors and services and all these things that will grow up around the ecosystem that will make it simpler. But we're not there right now, and that's why when the person in front of you asked before about like should I run a service mesh, it's not a simple question right now because it's very complicated, and I think what I tell people, I'm somewhat infamous at these like conferences where people love to tell you about all the new things. I'll like tell you to stay on your monolith because it's easier. So, it's not cut and dry right now. Like I think we're getting there, but we're not there now.
Yeah, and that goes back to the one thing I was saying earlier. While the service mesh does help to solve complexity and bring some semblance of control into some of the complexity in your containers and microservices, it introduces its own set of complexities. And I agree with Matt. I think what you'll see here is that tools are going to evolve to help with that complexity. I'm a strong advocate that your CI/CD process has to be a mature process for handling your source of truth, and you manage those changes through your CI/CD process. And if you've got a strong hold on a very mature CI/CD process, that helps a lot. But I'm also very much aware that I failed 4 or 5 times creating one of those types of pipeline processes. So those aren't easy to build either and do it properly in scale. So complex problems are complex. So I would also say be cautious about trying to adopt everything all at once. I mean, you can grow into it. Definitely understand what you're getting into, learn along the way, and as you're learning, understand what those pieces are doing, so that you're only using what you need. Don't use everything that's there just because it's there, because that's more complexity than what you need.
And that's one of the things we're actively working on the Istio project, at least, is trying to make that base install smaller and easier and simpler, so that you don't kind of get overwhelmed with complexity right away, that you can just take routing, just take load balancing, and just take little pieces. I will say that, sort of talking about the future, Google actually is not at the serverless part, but in terms of like running microservices, we've been doing this for a long time, and internally, I don't think about any of this stuff, right? I don't think about security because it's taken care of. I don't think about the quota system other than having to configure it because it's just there and there's a team that runs it, right? There's a team running all these things. It's like there's vendors, and I think the industry will get there too, where there are vendors providing these things, and you just say, oh, I'm picking up that service from that company and that one from that company. And you don't have to run all this stuff, right? You just pick up the parts you want, configure them, and you're good to go. And I think that's where we'll get.
Yeah, I mean, that's to some extent the motivation here is to take the practices that we've been using and turn them into software that everyone else can get their heads around. So it may seem complex, but like it's even now, I think it's less complex than you assembling it all yourself. And I think in the project, as we work to make it kind of incrementally consumable, then people can pick up the pieces they want, right? You guys have to keep, we, the community, have to keep the project honest as we go, that, it has, functionality and user experience are both equally important. We have to have the right way to consume these things incrementally. Otherwise, it's a fun science project for all of us, but nobody uses it. Right?
I think one of the huge benefit is if you're looking at the perspective from developers, and their jobs is much easier, and they can be more focused, and also they can be just like, you can think of frameworks developing around those Istio mesh, and you can just using those frameworks to writing services, and that aspect is very scalable.
Okay, question? Over here.
This is a question for Matt. At Lyft, how does Envoy help with distributed tracing? And this is from a perspective of like one of the difficulties is threading the context through the application and then out the other side. Have you got any techniques, experience with that?
Yeah, this comes up at every conference. It is the thing that I warn people about the most. So my standard disclaimer is, you know, service mesh is great, rah rah. It's not totally magic, and mostly around trace context or context propagation. And you know, won't have time to give a whole talk on this. It's a pretty complex subject, but the industry has done a relatively poor job of helping people do context propagation. It's a hard problem, just because there's no standardized way of doing it, and in fact, in certain languages, it's really hard. Like Go makes it very difficult to do. I am hopeful that with libraries that are coming out, like OpenCensus and also, you know, some of the open tracing work and stuff like that, I hope that that's a vehicle for making this process easier and better. My big recommendation for people that are thinking about rolling out a service mesh is the first thing that you should do is think about context propagation, and you should start updating your services and centralized libraries to do context propagation right now. And that's typically, the actual mechanics of that are not complicated. It's like look for a header, store the header in some context, and then forward the header out the other side when you make outbound calls. But given for a larger company where you might have hundreds of services and you're trying to get people to upgrade, it may take you 6 months or more to actually make that happen. So we had foresight at Lyft to know where we were going, and we actually started the context propagation process very early. So by the time that we were ready to do tracing, we already had the context propagation code in place. So we implemented tracing, we flipped the switch, and we had 100% coverage. But if you don't think about the context propagation now, you won't get that. And tracing is one of those things where I actually think that one of the reasons that tracing, I don't want to say has a bad name or people are more dubious about its value, is that tracing is really only valuable if you have almost 100% coverage. If you don't have 100% coverage, it's kind of useless because you don't know where the gaps are. So the service mesh can give you 100% coverage, but if you don't do the context propagation, you won't get that. So that's my advice, is for those of you that are thinking about rolling out the mesh, even if it's a long project, 6 months, 12 months, 18 months, think about context propagation now and how you will do that. And even think about what tracing provider, I'm sorry, I should stop because I can go on and on and on about this. You need to think about what tracing provider you might use, because then the headers are different. It's kind of a mess, but it's something to think about.
Yeah, and it's probably worth noting that in Istio, while a lot of things are magical, you just turn it on and you get all this value for free, that is one of the areas that it doesn't come for free. You do have to make those modifications. Even in Istio, we can't do them for you. The mesh can't do it for you. You have to do this.
And a second shout out to OpenCensus. There was a talk, I think, yesterday about it too. Definitely look into OpenCensus. If it meets your needs, use it. We're putting a lot of effort into it. We Google, not we Istio. The other thing to note, actually, yeah, do context propagation. Context propagation is for more than just tracing. There are lots of really cool things we can do with it in the future that, for example, make the metrics better by knowing where things came from. And yeah, there's a long list of benefits you get with context propagation beyond just tracing. So please look into it.
All right, I think we have time for one more. I'll go this way.
Today in our environment, we do not have Kubernetes yet, so we cannot count on it to deploy the data plane, the proxy next to the service. We still have to do that, I would say, the traditional way. And we also have a homegrown service mesh, and the way we bring the data plane is that the data plane is a library that we just attach to our service. And can I dream about an Envoy as a service? Or you were mentioning that just now that at Lyft, the communication between the service and Envoy is via a library. should I understand that it's a library that you attach to the process that communicates to Envoy? And next question is, can we know more about that?
So the library that I'm talking about is in each language that Lyft uses. We have a thin library called Envoy Client. So we have one for PHP and Go and Python. And that library is not very large. It's like 100 or 200 lines of code. But basically what it does is it guides developers into simpler RPCs. So instead of having to know to connect to Envoy on port foo or whatever, like it'll do that for you, and you'll be able to instantiate an Envoy client and say, I want to talk to this service. It'll set up sensible defaults for retries and circuit breaking and things like that, and then it'll allow you to override it, and it'll do context propagation. So that's like the most important thing that library does. So from a developer productivity perspective, I would recommend looking into that, just because I think it's a way to abstract the mesh a little bit. This question comes up a lot, and I'm going to go look into it, because I don't want to say that we're going to like open source this code and maintain it, but it's the kind of code which I think I can just copy somewhere and just show it to people. But yeah, basically just drop it, because it's not that much code, but I think it would be very instructive. So this comes up a lot. This will be my next reminder to go and think about that.
So I think I'm going to have a different take on what I think the question was, which was more about having Envoy itself be a library that you can. So if your application is C++, then you would be able to just sort of import the Envoy library and build a binary that's both Envoy and your thing. No, is that not your question? Your question was his?
No, but it's not. My service is not C++.
Right. So yeah, there's two things here. So one is that. So speaking of dreaming, I have a dream that, at least for gRPC, we'd be able to get to a place where you don't need the Envoy stuff. You can actually you can get all the benefits of the mesh just from that. And it already has some of those parts, and that's what Google has been doing internally. But Google actually is switching from that to a sidecar model, where we actually do have a sidecar, but the sidecar doesn't proxy the requests. It's just used for all that extra logic, so you don't have to write it in all the languages. So I built that internally at Google, so I have a personal interest in trying to build an open source version of that, but we don't have that yet. So I think there's really cool stuff we can do here, and again, it's just things are so early. But yeah, we'll look at it.
All right, great. Well, thank you for having good questions. Thanks for everybody answering. We'll be up here for a few minutes after. Thank you very much.